In this program, I want to take a look at secondary cells. A secondary cell is a rechargeable cell, unlike the primary cell, which only has single use. In order to be a secondary cell, the reactions at the cathode and the anode can easily be reversed during the charging cycle. A NiCad battery is an example of a secondary cell. Let's look at what's happening during the discharge of the cell. Here's the reaction. You don't need to worry about having to memorize the reaction for this cell, but we should be able to identify who's being oxidized and who's being reduced. To do that, I want to start by identifying what the oxidation states are of the species in the equation. Here we can focus in on who's being reduced or getting smaller. Here I see nickel is being reduced. This reaction would occur at the cathode of my cell. Here's the complete half reaction for it. Now, who's being oxidized? You should be able to spot here cadmium's charge is changing and increasing, a sign of oxidation. And this occurs at the anode, or the negative terminal of my battery. And here's the equation for it. During the act of charging, we reverse the direction of electron flow. So here's what would be happening. First of all, at our anode, we would be reducing the flow of electrons, moving it in the opposite direction. And similarly, at the nickel. So these are the reactions that would occur during the charging cycle. The electron flow is essentially in the opposite direction. Well, why can't all batteries be rechargeable? It's because the products of discharging don't disperse. In this case, we notice the presence of both solids, the nickel hydroxide solid and the cadmium hydroxide solid. They stay in one place, allowing for the reversal of the reaction. Many primary cells produce aqueous or gaseous products that spread out and hence not easily reversed. Here are a couple of secondary cells we should be aware of and their pros and cons. First of all, the NiCad battery that I covered. Find them often in flashlights, solar lights, household uses. They essentially divert material from waste because you can use them about 20 times before having to replace them. Their main drawback: cadmium is a toxic metal, and they also are limited in how much voltage they can provide, which is usually about 1.2 volts. Remember that the metals involved determine the voltage of the cell. The lithium-ion battery, this one you'll find often in a cell phone or in a computer use. They also divert from waste, but they're higher voltage. We can often get almost twice the amount of voltage out of these cells. As a result, we can tend to get a lot more energy packed into a smaller space, so they tend to be more compact. They are, though, more expensive than our NiCad counterpart. And finally, the lead storage battery, which has been around for a long time. The lead storage battery also, because it can be used over and over, diverts materials from waste, but it's capable of delivering a high amount of power, especially current, by arranging them in series. Hence, you find them in a car battery, but they are rather heavy. Anyway, that's a quick tour of secondary cells. Hope you found that useful. Thanks for watching.